Hello everybody, welcome to another stream. How are we doing? So last stream what we got started with is doing the ray sphere MIP level calculation thing. So now it means that we've got this material, just sort my levels out here. We've got this material that I've made, which is done based on the normal basically, and then it's got this sort of like noise applied to it as well, so it adds it just changes the color a bit. So it's got this high frequency noise, and basically when you look at it off in the distance, it selects the right MIP level, so you don't see this high frequency noise there. So we've got all that working, which is great. So now we've got textured spheres from a procedurally generated texture. Well, sorry, set of textures, right? Because it's a PBR workflow, so it's called a material. Now, what I would like to do is, before we build a whole sort of editor, which will allow us to make procedurally generated materials easily inside, I would like to sort of build a few of them probably before building the editor, and probably make a couple of like test scenes where we sort of put them all next to each other and just see how it looks. So the one I wanted to get started with today was trying to do something like a volcanic kind of ground or rock, where basically we generate a sphere which has this on it, or this sort of look, and the best thing about this one is that we've got some stuff that can go in the emissive channel, so we'll be able to see the bloom that we've been working on as well coming off the actual surface of the sphere in its own way. And again, this is like a realistic look. I don't really want to go for a realistic look. I want to go for more of a stylized look, so something that's just not real basically. So let's get started with just double checking. So end of last stream, I made it, I kind of had hot code reloading in place, but what I didn't have is it hooked up to the point where if I changed the source file, it rebuilt the SpearV file, and then that automatically. So I've basically just whacked it in somewhere to get it working. But I'm thinking, yeah, because right now if I change something, let me put the debug octahedral shader on. It takes about 4 seconds. So, and I noticed if I turned off optimizations, we can, so turn off, don't run SpearV opt basically after my compiler. That should save another 2 seconds or 2.5 seconds. But I wonder if the driver, when it takes the SpearV code and loads it into the GPU assembly, or executable code, does that then suffer because SpearV opt hasn't done an optimization pass, and it's just left with my terrible code gen? So let's just see if we can test that by going into main.c, because I've just thrown it in there. Graphics shaders. So if I take out the dash capital O, then if I just run that again, and now let's see how it behaves, or how quickly it changes, right? I wonder if so let's bring up the profiler as well, and then let's just zoom out. So it's about 8 milliseconds there for some reason. What's that? Oh yeah, because we're kind of regenerating the material every frame, so it adds more times and stuff, and uploading things. I don't know what it's doing. Right, so let's go to the shader. Let's undo that change and see how long it takes. 0, 1. There you go. Perfect. Now it has introduced a slower shader, which is interesting. So this shows that the driver, although it does have some optimizations, obviously, it doesn't necessarily do optimizations as well as SpearVops does. That's good enough. We don't need to... Yeah, so all we want is quicker reload time, and that's great. That actually took a few seconds. Oh, interesting. Oh, this one's more complicated? Oh, okay. No. Right. Okay, so I guess what happens is when I enabled this, it made the test material shader more expensive to compute every frame. So that's where this came in. Okay, so I put this back. 0, 1. Huh. Right. So maybe then the driver does do optimizations, and it's done far quicker than the SpearVops optimization pass does. So maybe, okay. Well, on this AMD driver at least. We don't know about the other ones. That's interesting. So yeah, now I've turned off the optimizations on the SpearV CodeGen side of things. It just reloads even quicker. So awesome. All right, so now we've got our sort of environment set up. This is what we're gonna have. We'll have something similar, right, where we have a way to also view the textures and view things at different points in time in some form of like editor. But until then, we're just gonna make a couple of materials this way. So how do you make something like this? Well, let's go to IQs. Inigo Quales. He's got his blogs or articles. So there's one, procedural noises. So oftentimes when you want to make procedural materials, you pretty much just start with the procedural noise. So there's one called Voronoi edges. What's this Voronoi? Oh, that's to turn something into that, okay. So this kind of looks... Where are we going? Well, I guess I closed the Discord now. Yeah, so I guess this kind of looks like this, right? You get these sort of edges, right? So this is how we can quite easily get some edges based on a coordinate. Now this is two-dimensional. We have got a sphere normal that we're working with. So we're shading based on the normal. And we, pack it down into an octahedral maps texture like this. So it just maps down into a flat texture, and each one of these triangles represents like an what you call an octant. It's like an eighth of a sphere. That's what it maps to. So essentially, we want kind of probably a 3D Voronoi noise. And Yeah, so I guess we can try and understand it a little bit by skimming it here. So anyone who has used Voronoi procedurals to create reptile skin texture or dry ground tiles know that when taking F2 from F1, sorry, taking F1 from F2, I guess, and thresholding it with a width of the lines, separating the cells have inconsistent width, which in an annoying, okay, I guess, which is an annoying problem. Techniques exist to alleviate this problem, but they are only approximations. Here we will find an implementation of the Voronoi noise that generates mathematically perfect separation lines, and which is fully procedural that runs, okay, pretty quick. Yeah, and then I guess you want to have a sort of a distance field here to help do some interesting stuff with. The problem is when subtracting the distance to the closest point from the distance to the second closest point, what people know as F2 take F1, Voronoi, is pretty close to a cell border generator. Indeed, the borders of the cells happen at locations where the two distances are equal. So the function F2 take F1 takes the value 0 exactly at the borders of the cells, which is super useful. So I'd say it's pretty normal that one is tempted to simply smooth step F2 take F1 between two small numbers and call that a cell edge. That sort of works, but not completely. F1 take F2 take F1 is not a distance, really. It expands and contracts depending on the distance between the two cell points in each side of the edge, which can change wildly over the domain of Voronoi. So this is a reference implementation. Right, let's try and read this and understand. Hey Geeko, how you doing? I'm not doing too bad, thank you. I'm actually doing pretty good. Yeah, doing pretty alright. Finished a nice big task at work, so I get to start on something different, which is pretty cool. This project's going pretty great. We got sort of proper MIP map. Like selecting the right MIP level for the sort of texture we've made, which is pretty sweet. So we're just about to get started on making some procedural textures. And, you know, yeah, it's going to be awesome. We're going to make this sort of volcanic ground looking texture. Test out some emissive as well inside a material, which would be cool. So you're taking an X, which I guess would be the pixel position. You floor it and make P, you fract it and make F. So I just assume that gives you a grid, basically. So that snaps it to an integer. Yeah. That gives you the remainder. Or the remaining part. The fraction part. So res 8, so I guess that's how big it is maybe. So you're going from -1 to 1 inclusive. And then there's some randomness applied to that sort of integer rounded point plus b. And b is just like -1 to 1 inclusively across 2 dimensions. And then, right. And then you get some sort, you take that away from b, and b is what? Okay, yeah. And then squared magnitude gets you the distance. Apparently. If distance is less than res, how big a cell should kind of be or something like that. Oh, then you start changing res. It was less than res. Oh my days. Who the hell made this one up? This is crazy cool. Yeah, this was also thought about before computers, I remember. It's named after a person. Voronoi. Yeah, it's made by this guy in 1800s probably. Pretty bananas. Classic thing where tons of cool stuff was made before even computers were around. So dy, and then you just change dy, okay. Right, interesting. Then you square root the result, and you apparently get some distance. But yeah, he's saying that it's not a good distance. So there's a fix. Yeah, I'm not going to bother reading all of this, but he basically fixes it. Wait, was there a get border? Huh, what's this get border thing then? We're not seeing it in this code. Oh, right. So get border uses this sort of distance function. And you take the difference between... Right. Okay. But yeah, he goes and sort of fixes it down here. I think what we want is probably... So we probably want this bit in 3D. Because we're in on a sphere. And we've got 3D coordinate. We've got a sphere normal. But yeah, so when we go on shader toy and find some example, because I've seen some on there already. So shader toy for Ronnie. Let's do 3D. So yeah, so this is the pattern applied to a sphere. Now, if you take a look, some of them have got a very dark center point, meaning that's basically 0. And then a distance of 1, I guess, would be the white. So you'll notice that not all of them have a very dark point in the middle. That's because it's three-dimensional Voronoi noise. And that will mean that the distance is somewhere either or the center is somewhere outside the sphere or inside it, right? Sorry, the center of that sort of cell, right? Yeah, so there is so I wonder if we want that behavior, but there's some other shader that I saw where someone basically corrected it. Yeah, here we go. Someone's corrected it to make it such that it sort of just projects it back down to the sphere, which is probably a little bit incorrect, but yeah, still look good enough. So maybe we should do the one on the right. Because then... Yeah, I wonder. Well, let's go back to that. Is this even correct? Oh, for crying out loud. Go back to... Oh, it's made like smooth versions of it. It's interesting. Oh, that looks nice. Yeah, like a honeycomb or something. Actually, no, probably not a honeycomb, but yeah, something like that. Yeah, I wonder. Yeah, so these distances are going to have that sort of like. Yeah, so I think the one on the right though is still going to be a little bit wrong because it's not really. That's a little bit incorrect there. There shouldn't be 2 points there, maybe. And they should probably be more centered. Or if there are 2 points, they should be more centered. You can sort of see how some of them sort of split up, basically. Yeah, so you have one which sort of splits up into 2. Hey, Pacer up. How's it going? Yeah, I'm not doing bad, thank you. Doing pretty alright. Yeah, it's had a pretty good day at work, I guess. Onto a new task. So, that's pretty cool. Then here we're actually generating some graphics and stuff. Procedurally, which should be pretty fun. Right, so this is where he sort of projects it back to the sphere. Scan the center of the cell in object space where 0 is center of the sphere. Cell centers have to be close. Each cell is one. Move the random point in the currently scanned cell directly to the sphere surface. See, I think this is... Like, if you see some of them, they split up, like this one is split it up. I think one of these might as well here, if you watch this one. Yeah, see, it's split into 2. But that should just be 1 point. There's something a little bit off with this code, to be honest, when it sort of corrects it. So I'm wondering if we really want the corrected... Like, how's it moving it back to the sphere? So the distance to the cell... This probably shouldn't be too hard to correct. The center of the cell in object space... Right, that's what OS stands for. Where 000 is the center of the sphere. Obviously, right, it's object space. Same as local space, right? So cell center says that random point plus that B plus a 0.5, okay. So you've got the sort of a length to that since 0 is where the sphere is. Yeah, so it's the distance towards the center of the sphere. So they take away the radius of the sphere, and that's how you get to the right. So maybe yeah, so it can be both inside the sphere and outside the sphere. Now what it's saying here then, so you find a kind of working mapping for the texture last time. Obviously you weren't sure on the mapping to make it seamless. Yeah. So I decided to settle on, so what kind of made the most sense was probably the cube. What kind of made the most sense was probably a cube map. But that's 6 sides or 6 textures basically, right? So it's a lot of textures and stuff to manage. So what I ended up settling on was the octahedral mapping. Ignore this is just me generating some random noise on top of it. But yeah, so it maps an octant, if you can call it. So each of these triangles is like an eighth of a sphere. It maps that to a texture. You get a tiny bit of distortion, and the way it wraps around the edges here is not predictable. So when it goes off the edge here, it doesn't wrap all the way around to this side. It actually mirrors down to here. Yeah, so you come off here and it starts up randomly here again. So when you have if you used to follow a pixel going across here, it would take that sort of movement where it goes down and then it comes up back here. So it's a little bit weird, but we don't really have that problem except for if you take a look here, when we have a very clear straight line across that texture. What am I going back over there for? Scene. When we have a clear boundary, we are seeing some aliasing here because I'm using a repeated sampler and grabbing the same pixel again on the other side. So when it's blending it with itself and then getting just the same color, right? So it should be blending it with a red. Yeah, I wonder if the other sides do it. Let's have a look. You see, the other sides don't do it. They sort of actually blend it, yeah? So if I'm going to solve that problem, which I might not have to, because if we generate random textures, we might not see those seams. But we either got to put repeat the pixels around the edges, do a 1 pixel border, and change how the code works a little bit. That does the sampling basically, or the reprojection, which adds a little bit of a cost, I think. Sorry, what's the reprojection? The mapping to an octahedral map. I've just got to change that code a bit. Or, yeah, what else would we have to do? Yeah, what other solutions are there? Yeah, I think it's just all we just don't do it. So basically, if you want to have a straight line map on an object, it needs to start in the center of the texture to take a curve to one of the merging sides. Yeah, so what happens? See, we never draw in this space. We never generate our texture. Yeah, we never generate our texture in this space. We always generate it in sphere local space using a sphere normal. So it will use a sphere normal and then translate it back into this space and write a pixel. And that's all we're ever doing. Or we're taking a normal, translating it back into this space and reading a set of pixels and sampling. We never write directly in that. But yeah, the way the projection works is that we used to draw a straight line that goes across here to here. And these are the corner pieces, it sort of goes down and then it comes back up here. And then same on this side as well, I think. Yeah, I just have to. Yeah, so it's definitely counterintuitive. But it means we can have, instead of 6 faces for a cube map, we just have just one texture, which is great. Came across some stuff and playing around with platonic, another regular solids, trying to texture them. Yes, I see. Yeah, it's probably very similar, right? Because this is just an octahedron, basically UV mapped, right? And then you're just making the sphere sort of like use that. Cool. Yeah, so I reckon we can fix this code because it's taken a single cell and it's produced 2 different center distances. Maybe. I don't know. We'll see. So it's 3D Voronoi noise. So imagine if you've got your sort of sphere. Okay, draw this circle first and then put the point in the middle. So you've got this sort of like Voronoi noise cell, like that. It's 3-dimensional, right? So it's kind of, okay, sorry, being a bit of a twat. The center point's here. So effectively, we expect there to be, this is the center point like here on this. So this is the sort of shape you're seeing on the surface of the, like where it intersects here is the shape you're seeing. Right. Interesting. Yeah, that's what I meant. I'm trying to wrap my head around how it would procedurally generate. So it merges the edges, reminds me of generating repeated maps, but those were 2D. I suspect you're doing, use some of the head work. So respect you for doing some of the head work helps. Lots to grasp this. Yeah. Yeah, so the way we're making it work is that all of the materials that get generated have to use the normal. And if they use the normal, then it's seamless. So as you can tell with this sort of thing here is there's a 3D, because another way you can think of the normal is a 3D coordinate onto the sphere, right? That makes sense, doesn't it? Yeah. Yeah. The normal is a 3D coordinate onto the sphere. So all you're doing is taking that 3D coordinate and then you generate the noise from that, and then you make the texture from based on that normal, and then it should be seamless. If your algorithm produces something that is seamless, obviously you don't do anything completely weird. So we have to generate in 3D, and then we'll compress it down to that 2D thing, which represents the surface of the sphere. So we're getting this sort of like overlap is where, so if you was to take this sort of vector, and if I can draw a straight line, that would be ideal, then you're putting the point there, right? Like, so I guess, can we draw some other sort of shapes that sort of look interesting? Say if I did that. Wait, hang on a minute. Let me do something really weird. I don't know if this would be the thing that gets generated, but let's just say it is. I'm trying to make a, so the center point is here, and the slice of what is taken up is sort of, where it intersects the surface is what you will see on the surface, right? And you're dragging that point back to here, so it's no longer the center of what is intersecting with the surface. And I think this is what we're seeing as sort of the problem. But why are we getting 2 dots instead of 1? I think is the question with this code here, because it used to be, or maybe maybe there is actually 2 points. Okay, so maybe this code is working fine. So if you see, yeah, okay. Yeah, maybe this does look all right. Right, should we just get going with this then? Hey, Peon, how's it going? Welcome back. Or Peon. Welcome back, sir. So I guess let's get this code in. And let's have a bit of a jam. And see what we can get up and running. So, X is the position of the surface of the sphere. Yeah. Alright. Just get some get merged, some split. Yes. It does look that way, doesn't it? So we're just going to drop it in here for now. Don't plan for this to be organized code at the moment. So we got, what do they call it, X. There's only so many X's you can get away with. Okay. Oh, it's HSL. Get out of there. Always type float 3. Okay. So let's put those in there like that. There's a couple of vector 2's here. Square root. And then ABS. What's the ID? It's just a float. Nice. So, right. Square root dot x square root. That ID is interesting. What does ID do? Is it figuring out which cell it is or something like that? I don't know. Returns the closest, second closest, and the cell ID. Yeah, okay, interesting. So you can color it based on the cell. Pretty cool. So this is like a... just gotta get rid of those pesky spaces. Alright, it's looking alright. Oh, this spacing, man. Ah, shoot, I did that. Right, how are we looking? So they've casted a couple of these into floats, right? So I need to... So there's a hash there, right? That's the random thing. So I've got PCG hash. What are we trying to generate though? P plus B. Right, add. Have I done some sort of like random thing? Yeah, rand F32 is what I did. Oh, it's above the simplex noise, right. So what do I need? I need a 3 version of that. So chucks into PCG hash, does some casting and stuff. Bit casts. Alright, see how that goes. See, I need a rand. Then it adds that. So B is already. I don't get why he's casted that to vector. Right, take an F. What's an F? Right, so let's just do sub. And then add. Alright. So we need to add sub scalar. Cool. Oh, okay. Oh, you're back now, awesome. Well, I hope everything's okay. Um, Distance between cell center and sphere center. So yeah, so that'd be a length of take away sphere radius. So yeah, so our sphere radius is just 1, isn't it? Is unit length. So I guess oh, we don't really have to do x, do we? Right, it's unit length. Jobs are given, so we just do a take. Oh, it's just a subtract because it's a float in it. Nice. Okay, so we're getting there now, getting close. Right, so that's alright, that'll work. This won't, because that's an X. What's an X? Oh, obviously, okay. Then I'll ask the both floats, just add those together. Normalize. Are an object space multiplied by sphere radius. Yeah, okay, so it's finding add R. Move it to the sphere surface. So where's X? Sorry, X is the, okay. R, that's what I meant, where's R? R is the random point based on P plus B. Yep. Right, so it's like rounded. Alright. R is the random point within the scanned cell relative to the fragment's position. Is the random point within the scanned cell relative to the fragment's position. Right. So that center of cell, right, I guess let's just carry on. Okay, so there's a subtract there, and it was the x again, so it's just a sub. Okay, then it's just a dot product, it's a squared magnitude. So if d is less than res dot x dot and then okay. Right, I believe that's looking alright. So let's just try this out. So there's a, let's just find where it's, okay, so it's got the position, and then it's just calling that, and then it's shading based on, so this is that sort of F. What's, is that occlusion of sample 1? What is that doing? Oh, I see. It's making it a bit dimmer based on the normal. Okay, so it's adding like a brighter at the top, darker at the bottom. Okay, so F times 1.2, and then mixing, lerping the color. What is the value that gets returned? It's like a distance, right? Closest, second closest. Right, it's taking the closest point. Yeah, I wonder, can we just do dot x for now? We can try it out a bit. So why don't we take... Right, so we've got the normal. Hey Zach, how's it going? Welcome to Streamster. How are you? What studies did you make? Well, I did go to college once, and then it was terrible. So I stayed there for a year, and then it was, it's terrible. But the teachers promised me the next year would be great, so I stayed on again like a fool. And then halfway through a year, I was like, this is terrible. So I, try and get my money back, and they basically say I can't. And then I try and go to uni, and they're like, oh yeah, you have to reset this year you're currently doing. And I was like, why's that? And they said, because you don't know Oracle database. And then, yeah, I was like, okay, well, I'm not doing this anymore. So I just went and got a job. Well, I went and just stayed doing my job as a C# developer. Yeah. And yeah, very terrible times in my life. I'm not going to revisit those. But yeah, school, it wasn't good for me. I hear some people, especially in some other countries, have good experience, but here in the UK, I think education, especially for IT, is pretty poor. It's very amateur at best. So yeah, I honestly just learnt online. I just followed lots of interesting people and learnt from them. You know, yeah. But thank you for the compliment. Appreciate it. Are you working on any sort of projects right now, Zach? What are you wanting to do? Hey Perry, how's it going? So if we take in N and then produce some kind of... Yeah, let's just produce a value. Oh, we've already got a value called V. Can't get any better than that. Right, we're passing N, which is the normal on the sphere. Yeah. And I can get probably rid of the simplex noise thing. I'll keep it around. Let's just do that. Okay, so... Yeah, we'll need the noise to make stuff better. Emissive strength. What am I doing with that? You are now 0. I'm not changing N anymore. Now this is where the fun begins. V. Rightio. So let's run that and see what we get. Oh, I mean, I understand I don't have much experience from other companies apart from countries, apart from Switzerland. Cool. I got someone from Switzerland who goes to my church. I'm currently second year of Counter-Strike, computer science, bachelor's program, and yeah, it's getting pretty interesting. That's cool. What sort of stuff are you learning? Yeah, I heard people in like what you call it, like probably the Nordic countries. Yeah, I think education there seems pretty good in terms of like you actually learn about a computer. Here in the UK it's like websites or databases, and they'll be like Java, and here's how you make a linked list, and then like, that's basically all you learn. And it's like, now you got to make a vending machine application, and it's like, it's like, this is 1 year off of getting a degree, and you're teaching people how to make a vending machine application. And doing it heavily in OOP. It was a mole, wasn't it? Oh man, what the hell's happening here? Right, I squared it, so I don't need to put the extra parameter in there. Jobs are good. And next one in, and that is okay. I need to dot x on there, so that's the closest. And then y is the second closest. And here we go. We've got... Ah! It works on one side. This looks really alien. But it doesn't work on the other side. For some reason. Which we've got to figure out. Isn't that interesting? Step 1 is kind of half complete. But fine, tried to install Windows 11. Failed to boot. Need to retry tomorrow. Yeah, fix the texture mapping. We got MIP levels now. Or correctly sampled MIP maps. It's pretty sweet. So we're just trying to generate procedurally generated materials, because this is what we're trying to build, is a system or an editor where we can like edit code and make a procedural material which has a bunch of sliders that you've defined, like, you know, scale, different colors and stuff. Just, you know, basically just you know, a bunch of different sliders for the material, like they're custom for each material. And then you can go ahead and make a bunch of materials from that one procedural material just by dragging a bunch of sliders and pressing save. And yeah, it's going to be cool. So we're just sort of actually making a couple of like procedural materials and seeing what sort of cool stuff we can make before we build the editor. So yeah, going to be lots of fun. So yeah, y o y. So that obviously gives you a value between 1 and -1. So you have to, because it's a distance, right? Or maybe it's not a value between -1 and 1, but let's just times it by 0.5 and plus 0.5 to move it in a value between 0 and 1. And see if that helps. And the answer is no. So the next thing to do, can I ABS it? Or is that... No, sorry, it returns a distance. Let's copy the whole comment for now. Right, so what are we trying to... So it returns this sort of, okay, the square root, which means it's guaranteed to be positive. Or is that right? No, sorry, you square it and it's positive, right? But you can square root a negative number and that can be negative, yes. I got it the wrong way around. Yes, if used to square root that. Okay. Yeah, sorry. Yeah, you can't square root a negative number. It won't work because if you square a number, it's always gonna be positive. Yes, so it's undefined if you square root a negative number. So, right. Interesting. Interesting. Oh yeah, we square it there. Or it gets the length squared, which comes from a... Yeah. That's just the dot product of itself, right? Good. So, yeah, it's you square all the components and then you add them all together. Yeah, so it's guaranteed to be positive. So, what is... So 0 should be the center of the cell. Right, let's monkey around with this a bit. So let's just to make sure we've got everything right. Right, f times 1.2 is occlusion. Yeah, so it's oh right, and then this why is the color square rooted? Oh, that's just to make it right. sRGB in that probably. Hmm. Yeah, so it looks like oh right, what's SC? Sphere center. Oh, that's in like a world space, is it? Yeah, okay. So that's just producing right, then it's timesing it by 4. Right. Yeah, so what's that times by 4 doing? Right, it just makes it more. So we ain't got anything like this at the moment. So let's just keep the sphere one here. So if they put it down to 1, yeah, we was kind of getting something like this, right? Where it wasn't very... no, we wasn't really getting something like this. Yeah, we could multiply. If we multiplied it, we got more. We get more of those. But yeah, it's interesting. So if we scale it a bit, see how it looks. Scale n. So this could be one of our parameters, right? This is probably a very common parameter on all of the shaders that you pass in, which would just be scale. Right, so see how that looks. So that blue is coming from a blue light, which is up in the sky, by the way. And that just completely messed it up. It didn't really help anything at all. Interesting, at least. Let's put it back to 1 for now. We can... So what it is, V, 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 and then linear to sRGB, which basically does like a square root kind of thing. Well, yeah, something's close to square root at least. So it's albedo. I wonder if I copied any of the code wrong. Let's have a look quick. Our sphere radius is 1. I think so, right? Yeah. Oh no, but right. Yeah, you probably want to make it a length of x, to be honest. Because you're multiplying. If you're scaling it, then right, we'll change it. Okay, so let's put that to 4 and see what happens again. I wonder how good my hashing function is as well. Oh, that's done it. Look at that. Cool. We're getting some... Oh, that's horrible. Yeah, we're seeing some clear edges. So it appears that... I don't know what it is. So I'll look. So go to the texture we put it into. Oh. Yeah, we should probably have a way to make the different textures actually and put them out. Yeah. So what we're going to do is we'll have a sort of a hash define and we'll call it so if mat equals 0, then we'll do, so what we're trying to do is output kind of all this basically to some degree. And the other one was emissive. Oh, I was just done emissive as a beta, haven't I? That's alright. Yeah, so this is what you can change. So the first material is going to be the debug one. So we can just switch between it very easily. So it would just be something like albedo equals sine of normal. So take the UV, unpack as octahedral. Done. Yeah, that was it, wasn't it? So scale as well, we'll chuck up here. It's pretty common. Yeah. So UV S, where's S used anywhere? For the noise, wouldn't it? Let's comment that out for just a sec. Cool. So now we can just have this running. Oh, it is sine. So dot XYZ or RGB, whatever way you want to read it. Oh. Oh, VA. That was the height. Interesting. Yeah, I'm also going to have like a height map, I think. See, we might do some parallax occlusion mapping maybe at some point. The problem with parallax occlusion mapping is the silhouette. Is there's our debug shape. So now we should be able to open up the texture viewer and plop down here. And so these are, well, probably make this always on top. So we got to see where those edges are appearing. So these are where the edges are in the texture, right? So if we recompile now, what do we get? So the triangle is kind of here, and we're not getting it on the edges per se. This sort of circular pattern. But yeah, there's an artifact there, here, here. So there's something a bit weird going on. Let's just say the least. So maybe we've just copied the code a little bit incorrectly. So we'll look into that. Let's change the scale and see what else we get. So let's change it to 2. Right, 2 is a bit better. Let's put it to 8. Oh no, 2 had an artifact there. 8's got tons of little artifacts as well. So, yeah. It's interesting. So let's see if it's the reprojection code. Yeah, so the reprojection code could be causing it. Or it brings it back. I don't know, so let's have a look. Yes, it could be the distance to the cell in the center of the sphere. It could be some of this code here. Cell centers have to be closer than this to be considered. Each cell is a 1x1 cube in 3D space. And with 0.5 we get almost all cells that intersect the sphere's surface. Without this check, the points of the scanned cells, the points of all scanned cells get mapped to a sphere surface, and this will lead to sudden jumps in cells because they scan different cells, right? Yeah, I wonder why this is not getting that sort of... I think I've just copied the code a bit wrong. Let's just double check it. Let's minimize that for a sec. So, floor fract, yep, length, res at 100, whatever that means. B is this ijk vector, cast it as a float. So take away f plus sort of a rand. Now it could be that my rand function just ain't great. We could take this hash. This doesn't look too complicated. And that way we've got the same code that runs, right? Let's just try this out. Okay. Nearly that. Cool, so we just try that hash function out. We'll see if that helps. We can always put it back to our rand function. All right. So that looks all right. Oh my days. Yeah, this looks all right here. Next one is Oh, I did a subtract. It's an add. Right, so that could have been a clear problem. Yeah, no, it's definitely a clear problem. That's why it probably didn't shut up on one side, maybe. Yeah. It's probably what's causing the problems. Right, so ignore it's an add. Norm, multiply, yep, subtract. Yep. Yep. Add dot product. Cool, it's looking alright now. Let's give that a go. We can always change our function back, but save that. I thought I minimized my thing. Oh, did it crash? So if I save an invalid file, it will crash. Anyway. So that needs to be a scale. Cool. Alright, see how this looks. There we go. Looking much better in it. We're not getting those sort of weird artifacts now anymore. So let's use our custom hash function. Or random one instead of this one and see how different it looks. You know, maybe it's better to bring up the texture viewer again and see it, just see the whole sphere. It's going to not obviously be the same, right? It's going to be, it's an octahedral map, so it definitely looks a little bit weird, but it looks distorted. It's fine. It's going to be distorted. All right, so let's keep that above all the other windows. So rand float times, okay, so when we save this, it's going to change already. 3, 2, 1. Okay, that's all right. It just looks different. It's good. So I could probably get rid of, yeah, I think it looks the same quality. I think it just looks different in terms of the positions are different. That's all. That's fine. That's what we want. So we've got the scale parameter, so we can choose how big we want these things to be. And then we've got these kind of distances. So my concern is though about these ones, they kind of look quite, you have to see. Maybe that'll make an interesting thing. For those who have joined since the beginning, we're trying to make kind of like a volcanic ground looking procedural texture, or volcanic rock, which would be really cool because we get this sort of like emissive that we can test out in our PBR textures. So we've just used this sort of Voronoi noise, or Voronoi noise, to generate this sort of pattern here. And now we can use this to now make, so this obviously represents a single tile. When it's at 0, you kind of get this border, and that could be where the sort of quote unquote lava is, and that could be the emissive part. So yeah, we're just playing around, we're generating some procedural materials, and in the future we'll have some form of editor where we can expose some properties like scale, for instance, and edit these things live and generate different actual textures that get used based on a set of parameters and export those, which would be cool. So that blue is coming from the blue light. I should probably get rid of that for a second. Or at least, so I've just got a couple of hard-coded lights. I need to come back and do proper set of lighting. After we've got the editors in, we'll do that, but ain't for a while. Okay, so when we next reload the game, it will do that. See, the next thing to do now is to sort out this Voronoi noise and do it properly to the point where we can probably have these sort of like hard edges. And then should we start off and just make the emissive part? Right, that's the fun part. Let's get the fun bit done. And then we'll do the rock part. And then we'll maybe probably make some sort of add some noise to make the borders a bit less obvious, right? Because the borders, you might want to have some noise to sort of make the borders seem a bit uneven rather than sort of straight edges like they're, you know, formed from maths algorithms. Right, I'm just going to take a quick break, get a nice drink, and I'll be right back. Right, welcome back everybody. So, let's take a look at the blog post again. And what it's saying is, if you do sort of like get border thing with the Ronnie distance, if you smooth step it, is that what you want to do? Do a smooth step. Ah. There's also like a second closest distance thing as well, the parameter that we have, and also a cell ID, which is pretty cool. So you can color it based on the cell. So I think let's get our emissive as another parameter as well. So yeah, some other fun stuff you can do. So let's call this result R. So you've got the sort of the closest distance. Distance 0. Distance 1, which is like a second closest one, which is interesting. I'd like to look at that. And then you've got like a cell ID. Now, it's not really an ID because it's like, it's the dot product between. Right, yeah, it's interesting. Oh, so it is like an ID. Right, interesting. So it's kind of, you probably could cast that to an int. So, or you could probably throw that into a hash function and just get a random color or something. So yeah, you can basically treat every cell kind of differently with that as well. That'll kind of be like an ID. Anyway, so let's rename this D1, D1, D1. How does that look? So that's the second closest distance. And you get this sort of like, that looks kind of interesting. This blue light's really annoying, but probably reorientate the lights so they're a bit better positioned, but yeah, it's definitely not what we're looking for in terms of a thing, but it's interesting we can get that. Anyway, let's go back to distance 0. So they were talking about if you were to smooth step D0 equal 1 take smooth step 0, 0.05 and D. So you get a very, value between basically, it's basically white. I don't know what we're looking at here. It would basically be white, wouldn't it? Right, that crashed the application. Oh, okay, that's just because the whole, oh, okay. First compile. Whoopsie. Okay. Right. So what does it mean by get border? I don't understand how that's the border. I guess. Is that meant to be the other way around? So when we were coloring it like this, so 0 would be the point and 1 is where the border is. Right. So in our case, R1's the other way around. No, that's not, is it? So is that black value goes to 0? Or does it go greater than? Can I clamp this between 0 and 1? Yeah, okay. So we did 1 take. Those edges would kind of be 0. that smooth step is basically just doing a remap, right? Yeah, but I think this is already the value that you want. You want 0 in the middle, and then 1 at the edge. So when it's doing that smooth step, so 0 in the middle, 1 at the edge. I wonder how it would look if you did. Okay, I'm coming. All right. So if I get build error, the thing crashes, which is okay. Something I need to fix. Almost okay. I know why my code didn't work anymore. Oh no, I don't. Edge 0, edge 1. No, that is right. Okay. Maybe when I map this into Spear V, it's not following that. We'll see. Right, I'll be right back. I just need to help my wife or something. So my wife found a big spider. Never can see it. Dun-dun-dun. So it's pretty big. So yeah, just gonna take that out, and I'll be back. Throw it out in the garden. Right, welcome back everyone. The spider's been dealt with. Quite big, just sat there in the bedroom as my wife comes home. Yeah, so the thing is, I vaguely remember there being a problem with this in the past when my smooth step functions were mapped wrong in SpearV. So let me just quickly go into the compiler source code and just double check. SpearV. Wait. GLSL 4.5. Sorry for that. SpearV extensions, yeah, extended instructions, these boys. Right, edge. Oh yeah. So I used to have it wrong, whereas that way around, and then whereas X first. So then I conformed to what those are. So let me just double check in the generation when we have smooth step. It's just copying them one after the other, isn't it? Yeah, it's not doing anything fancy. What about the abstract machine language generation? Alright, it's nothing. Cool. Alright, let's get out of here. Let's go back to doing some. Right, so the edge of... I guess the edge is too aggressive for this Voronoi code. So let's just run that like that. Tinker with the values. So 1 is at the edge. Right, I see. So we're kind of producing this sort of pattern now. So as I tinker with these, okay, that's just obviously just doing a remap, isn't it? It's just making that black area bigger. Right. Yeah, so it's interesting. So yeah, okay. So let's just take a look at some other sort of Voronoi edges. See what other people do. This is IQ's one here. So he produces right, then he's got a second pass which gets distances to the so without the second pass, what do you get? Hey Lupo, how's it going, sir? How you doing? I'm not doing too bad. Yeah, doing alright, just it's been working. Stuff like that, been good. How about you? 2 times this by 8, right, that's just the scale. C. It's the sort of MR is a vector 2. So is MD, so how are you vec 3 in a Oh, MD's a right. Yeah, this is a bit different to the one that we've been using over here. The 3D one. Yeah, so put it this way. If we just were to take his C.X and color it that way, what does it produce? So the borders are taking what? The borders are saying anything from 0 point whatever. Yeah. So here's just smooth stepping a particular. So what we could say is like, right, distance between, so in our case, so we've got a value of near to 1 in our case. So we could say 0 0.9. So this is where you want to have kind of like an edge. You want to basically say how thick. So this is another parameter. So maybe scale. Yeah, so this is one of the parameters. Scale. The other parameter is border thickness. And this is in, or border, it's basically like a distance, right? Yeah, so you can say 0 0.1. So what that means is you would go, yes, how's he getting it to color different? He's saying mix that color in. Oh, it's just in like a lerp, isn't it? Right, okay, interesting. So in our case, I guess we could do an if statement to say, oh, this is the border, rather than doing, you know, it doesn't matter, right? Oh no, but if you lerp it, then you get a sort of a smooth thing about it. Yes, another input parameter might be like, hey, what is that sort of like border color? So in our case, that will be, what's a nice sort of like fire red? This one here, maybe. That color just looks incredibly different on all these photos. All right. So it was like linear, no, sRGB to linear, and then unpack. And so all on alpha, 18 blue, 37 green, F7 red. Cool. So that border color, we'll just lerp in the color. So for our albedo, so we should probably have like what is a sort of the sort of inner color, I guess you can call it. So an inner color, should we go for a nice sort of like charcoal? Nice. It's not, yeah. Maybe let's go for like a charcoal color, I guess. Quote unquote nice. Maybe there should be a tinge of like brown to it. Earth. Check it out. Yeah, I've just been on this one. I got it open, I think. Yeah. We've been looking at it. But we're doing a sort of a 3D version. Yeah, IQ's got all the good blogs. Hey, proper cover. But what's my editor? Oh, it's Helix. So Helix is pretty cool. If you want to sort of a terminal editor like Vim, but you don't like all the Vim setup stuff or NeoVim setup stuff, and you want a config file which is just a config file and not a programming language, then Helix is pretty good. My only one gripe I have left with it is that it doesn't do. It heavily relies on the language server protocol, and that's not very good in C because C is basically a very difficult language to support in text editors. You know, just look at Visual Studio and how bad that is. So what I typically find is a dead basic stupid simple string cataloging system, if you want to call it that, where it just basically takes a function, or it takes a set of characters which are not white space, and then sort of puts that in a hash table somewhere or whatever. And then that's what shows up in the sort of autocomplete is pretty good. Just a dead simple thing for C. Whereas other languages like Rust probably benefit from like a language server protocol, but I don't really know. Because I did used to program in Rust, but I used to program in it without an LSP. Yeah, and Lua. If you don't like Lua, yeah, there's another one. You jump over to this. Yeah, it's using LSP. C ain't tedious. What are you talking about? What's tedious is having to download all those packages when you want to compile something. And dealing with terrible build times. And C, you don't get any of that. So we're trying to find out. Oh yeah, I want like an earth color. Well, this is clearly a color. I want color like ground, mate. A nice. Ah, this costs money. Let's go away from here. I want free color. Canyon clay. Not what I'm looking for, but it sounds nice. That's alright, isn't it? Maybe. Am I really looking for that color though? Maybe more of like a darker one, isn't it? That's why I googled like let's go back to the charcoal. I wanted something that was kind of Hmm. Ah, nice bit of blue on there as well, maybe. It's a tinge of blue. Finding the perfect color, eh? I think I want like an in-between of these. It's not really right though, is it? Um, this is what makes it stylized, I guess. Just put your own crap in there. But yeah, I was thinking maybe like a... I ain't getting anywhere. Ooh, this looks doable. Ah, damn it, Pinterest. Right, these are the that one right there. Right, 28. 23, 1B. Boom. Right, now let's get right in there. Okay, so 1 gets us a value of the edge, or a value towards 1. So what we want to do, for our beta at least, albedo, that should probably go at the end. Linear, or is it? No, sorry, sRGB. Okay. Cool, cool, cool. Now we could just do whatever here. So albedo, in this case, would be a... So... What was the trick he was doing? So it was like, it was a lerp with the border color. Yeah. So it was the color he wants for the border and the color from the... Right, then it's in the smooth step such that anything greater than this is 1, and anything that is less than this is 0, and everything in between that is smooth. Right. Clever. So we want to do like a lerp. What is Ven VS? I've never heard of it. What is it? A jewelry thing, or I don't even know. Virtual environments. Right. I don't really know much about that, to be honest. Radio, so we'll put the color in that we want. So I guess it's like, we'll say border color and then the inner color. And smooth step. Based on distance 0. Now, okay, so 1. So we might want it the other way around. Since the... Yeah. So we need to say, right, if you've got a value between 0. Let's say 6 and 1. 0.9, something like that. Let's just play around with it. Now hopefully this compiles, if not it's just gonna crash the program, but let's see. I think that's crashed it. Sorry, I got some compile error. Right. What's going on? Why didn't that do it? I did border thickness, not border color. Whoopsie. Right, and there's a border thickness that we can use to control. Right. This is good. Cool, so we do have the two colors now, although we're getting these sort of like, it's kind of looking close to what we want in a way right now that we've got colors. So like, because these are so big, we're getting they look a very circle-like, I think. Oh yeah, it's really selecting that. Right, so I think what we want to do is produce a different kind of... Yeah, it's a bit of a shame. I think we've got to tinker around with this. Yeah, there's quite a lot of room. Yeah, they're quite clumped up in some places. And then they're quite... But I guess that's kind of realistic, I guess, right? And, right, because there's a distance and we're cut it off by the distance, it does produce this sort of like circle, and you want this to preserve that sort of shape, isn't it? Okay, where was that other one? We just keep closing it. Right, so the way he's coloured, so he colours the inner bit first. I guess if you just tried this before and then it was just a smooth gradient, right? Okay. So that's just the distance. Yeah, so I think if you take away this second part where he gets the distance to the borders, you get kind of what we've been getting here. The very sort of circle looking thing. Alright, so maybe we need to do a second pass. But what's it doing on the second pass? The problem is this 3D Voronoi that we took basically behaves a little bit differently. I wonder if we can extend this to 3D. Maybe let's try and extend this one to 3D and then mathematically correct Voronoi cell interior distances, hence the correct cell borders. Alright. Alright, let's take a look at making this 3D. I don't know though, why is that one? The distances are not correct then? Maybe. Yeah, the distances to the edges, they're not distances to edges, they're instead a distance from the center of the cell, maybe. Rather than a distance to the edge. Right. I see now. Okay. Let's see if we can port this over. So let's try another one. So just call it X. So it's very similar in the sense of it does these things here. Alright, produces these two. Does this sort of let first pass? So there's also like a cell ID this one returns, which is interesting. I would like to see if we can keep that, because it could be useful for adding some kind of like randomness to each cell. So, right, it produces a thing called G. In this case, it's called B. And then the random thing. But now, so I guess it calls it G there and then O. So let's just follow it. So it's a hash of, I don't really follow the other ones. They're called IP, isn't it? Right, IP and FP. Okay, so GO. So it's adding IP. So it's very similar to the other one, but not got any of the extra bits on it. Extra adds and subtracts after. So random number basically add IP and G, and there we go. Right, so after you've done that, there's that sort of animate thing, which we're going to ignore. Now there's that R, which I guess this thing was doing all in one go. So it's adding G and O, and then subtracting FP. Then it's getting D for distance, I guess, which is the length squared of R. And then if D is less than MD, which we haven't declared yet. So MD is starting off at 8. Then that will be MD is now equal to distance. MR is equal to R. So these are some other intermediate ones to define. MG, MR. And then MG equal G. Right. So maybe these should be good to declare, but I don't know what to write them as. Just put them as 0. Sorry, good to initialize, that's what I meant to say. Then it does a second pass. Sets MD back to 8 again. So this one does it from like -2 as well. Oh, this one does it from -2 this time. Interesting. And then it takes your MG and adds it. And MG is a float. Okay. So it's adding MG to this. So I could just do, right, add S. Get these comments out of the way. Right, it's in the round again. Then does the R again. Now this time it doesn't do the D. Then it does if dot product between MR, which is a float, take R, which is a, right, it's assigned, sorry, scalar subtract with a vector. So it's MR take R. And the dot product, and then this, so that's a squared magnitude of that. Is greater than 0.00001. Then make MD equal min. MD is a float, right? So it's MD dot Right, so we've got to say multiply by a scalar, add a scalar, so R with MR, 0.5. There we go. Then normalize R take, so sub S, R take MR. Alright. Okay. So that's what we want to produce there. And then basically just return. Now MD is the float, so it's MD, then MR.x, MR.y. Hahaha. Cool. So let's try this version out. So this one's a bit different. He's using... Yeah, I'm not sure what these different ones are, to be honest. What does it return? Anyway. So let's try this one out. MR is... Right, R was the offset from... Right, and which cell... Anyway. So it's in like a grid basically around it in 3D. And then... Oh crap, what did I do? Oh, these are vectors, crap. No. I messed that one up royally. Does not add scalar anymore. Just a subtract. It's not a scalar. Okay, so in that case... What's the vector for then? Right, so what would that be? MR is R and R was... something like... Is the random point within the scanned cell relative from the fragment's position? Right, I guess it's the center point of the... C. Yeah, then it's using CYZ to do the... Yeah, so it's the point in which... Where it sort of originates from, right, I see. Right, we'll return the vector 4 for now. Well, we can just do... Oh, shoot. Yeah. We can always change what we return. Right, let's just return... Put that into D0, we don't care about the ID for now. And do a .x. Okay, so... Oh, crap. Let's just get this compiling. And we'll take a look at this new one and see what we got. It's a lot more expensive, I can tell you that. It's taking 30 milliseconds to generate a 4K texture. So it's a lot more expensive because of probably all these iterations going on. Also, there's that 5 iterations, isn't it? So it's 5 cubed. So 5 times 5 is 25. And then you got another 5 of those. So it's like 125 iterations per pixel, just here. So, yeah, maths. Right, there's that res that can go. Alright. So, that's interesting. I don't really care about the frame rate being a problem. It's just, it was one of, because this is the whole point of these things, right? You spend the computation, sorry, this is all done in editor time or build time, and it only really runs once. So it doesn't really matter. It kind of matters a bit if you're trying to, you don't want it to take days, for instance, and you're building all of your assets. So it kind of matters in that regard. But in terms of real time, it doesn't have to be real time. Okay, so we're in this sort of like smooth step thing. Let's just output. Okay, so we're doing. We should probably follow what IQ's done here then. So he's done like a 0.04 and then a 0.07. Let's just start there. See what we get. Awesome. Now the colors are the wrong way around. But this is looking good. Now we just gotta just pop that on top. Thank you. And we're just gonna swap the inner color and the border color around. Then what we can do next is change the radius, or make the radius programmable. So that's looking kind of cool. We want to make sure that we don't just get the inner color. We want to make sure that the inner color is probably lapped around with based on some other property. And you probably want to add some sort of like cracks on that, Or there's maybe some things we can do where we can monkey around with the distance value. Oh, yeah, this is gonna be fun. So let's take this sort of like, so there's a sort of like border thickness, right? So if we put this down to 0, how does that change? Right, kind of makes it a lot more smoother. Wonder how this is positioned on the screen. Do something like this instead. A bit better. Okay. So I reckon, right, let's start off at 0.04. Then what we're trying to say is this is where border thickness goes. And now we've got a controllable parameter where we can tweak this parameter here to basically control how thick we want the border to be, right? Cool. I wonder if you put that less than. Very interesting. Yeah, so I guess what we can do is we can take this value, times it by 0.3 or whatever, or 0.4 is probably the most. And that way this can be a value from 0 to 1. So when I expose UI, I like to think of it as like, if you've got something that is an actual measurement, just make it a value that's between 0 and 1, and then it's just a lot more easier to work with. So now I've got a value between 0 and 1 that we can use to control the border thickness, basically. Cool. Now the next thing I want to try and do is like, let's have a bit of fun, and let's like put some noise. Let's see if we can break up those edges a bit. So let's bring this down to something a bit smaller. Let's see if we can, like, those edges look very hard, right? So I was thinking, like, we've got this simplex noise here. So could we take that distance and like rough it up a bit? I don't know. Let's just see, right? So we go plus equals noise. So noise is -1 to 1. Then you say times 0.1. How does that look? Well, I believe we just crashed the program because S is not defined. So S was some sample position that was scaled. Okay. So what do we get here? Is it too small? Right, so yeah, clearly we're seeing like a, the noise now. But it's very high frequency. So let's go ahead and change the amount we scale the normal by. Looks a bit splodgy there, which is kind of cool, but maybe it needs to be like 30 or something like that. And then you start really seeing it as a... Yeah, so I think this is where you need some kind of like... You need to layer the noises. You need to do like more octaves and stuff like this. But yeah, so we should be able to use noise to basically break up those edges a bit and just modify the distance, perhaps. Although you probably only want to do it... Yeah, so I wonder if you... So if you apply... Let's see, right? Can we try something out? Why did it do out of 1? There's no point in doing that. Alright, let's try and have a little bit of fun. Let's manually put this in. So we did one at 30. One at... Another one at 10. Can we sort of just... What do you do? Do you sort of like add these together or something like that? Or do you mix? With a multiply, do you? I don't know, let's have a look, see what happens. Maybe not. Let's get rid of the 51. You probably... Okay, Maybe we could sum. You know, I gotta take a look at some examples on the internet. Oh, that just looks weird now. Yeah, so let's go back to maybe some other IQ's articles. It's got stuff to do with, would it be the FBM? Yeah, see, octaves, noise times A, so it's something like this. The way FBMs are constructed normally is there's multiple methods. Some noise function of our choice. Interesting. Yeah, maybe it's something like this we need to do. Sort of break up those edges a bit. We could give it a go. Alright, let's look at the FBM. Let's close this because it's just making my machine go and taking off. Right, so okay, there's a bunch of different okay, interesting. Right, let's take something like this. So the type of noise that we're looking at doing is I think if I just did random vector 2, I might do it. The problem is that random gets me a vector 3 back, whatever. Oh, we could sample the simplex noise, isn't it? I'll do it. Yeah. Cool. So let's just try that out. So we just took and passed in some form of X. So in our case, see, unfortunately, I haven't really got simplex noise 3D yet. I should maybe try and get one. So I was just using the XY of the normal, so it looks really weird when you go across one of the boundaries. But I think that's okay for now. Right, let's try and see if that is better. Oh yeah, it didn't want the loops to unwind, so to unroll. So he did a constant. Sorry, did a variable basically. Well, the 0 is based on like, yeah, minning with the frame number. It's pretty clever. Stopping it from. So in our case, that'd be graphics global. Have I got like a frame number? I could always just take the time though, that's another one. Yeah, I've only got a frame index, but I've got a time in seconds. So I take the time in seconds. So I'll just be cast it into a yeah. It's pretty clever. Or I could just have a field which is 0. Past, just read 0. Be M2. Where does M2 come from? Ah, it's a matrix, damn it. Sneaky matrix in there. It's F. Oh man. Matrix multiply? I've not got one of them. Well, maybe. I removed my matrices and I've just got ones that I need, so I've only got a 3D one. Okay, so it's just a scalar though, isn't it? Right. Yeah, so it's just scaling. Oh no, it's not. It's matrix 2 by 2. Ah, so F is scaling it. Right, so F scales it. And then it's actually in the right. Gotcha. So is that mole V? Let's just go to this. This one's declared. Just grab this. Just do it in line. So it's M2 0. So M2 0 was, or is, shall we say, 0.80 and then 0.6. Then minus an 8. Right, so you just take these. So it's scaling the matrix first. So this would just be a ls by f. And then we're simply just filling in this here. So that is, so x will be equal to, get rid of that one there. X dot, oh, x dot x and x dot y. Right, so the problem is you've got to put it in a temporary. So you'll call this n, I guess, and then x is equal to n. So this would be m20.x, m21. I don't need the third one because that's 3 dimensions. Now the vector in question here is x, x. Cool, that looks to be good enough. Just give that a launch, see what happens. Damn it. Redefinition of n? Crap. Okay, this would be called v, I guess. Alright. Let's see how this looks. So we should have hopefully got rid of the border. Maybe not. Or we made it 6 milliseconds slower. Okay, so that didn't really help much. Let's go back to... Right, so let's times it by 1 instead and see what happens. Sorry, if we just apply the noise directly on top, does it change? Interesting. So it's definitely a lot. Okay, so let's times it by 0.4 then. Yeah. Does not like me multiplying by a double. Because if not, it should cast up to a double and we don't support doubles. Right, it's looking a bit weird still. It's sort of made the edges a bit different, but the problem is that it's brought the... it's brought the... Yeah, maybe adding the noise is not a good idea. Maybe we need to... multiply by the noise? Oh, maybe that won't be good. Let's just see how it looks. No. Yes, adding by the noise is interesting, so you'd have to then clamp it. Yeah, so what we're kind of looking at is like, if we've got a border, I want to add... Yeah, I want to get rid of these sort of like hard edges, basically, between there. We could just... So I was thinking we could apply a bit of a noise to it. The other way is we could... Well, you know, blend it, which is in it here with this sort of smooth step thing, right? So you can produce a sort of a wider... But then you still kind of get the edges there, so I was thinking we could probably add a bit of noise now. Maybe what we want to say is if it's at the border, then apply a bit of noise. But so maybe we do that thing where we say if, maybe do that same smooth step trick. So the edge is defined at border thickness. Now you probably want to have like a noise thickness or whatever, I don't know. Let's put it as another parameter. Well, you could probably leave this one hard-coded, I don't know, but let's have it exposed anyway, so it'd be like a noise. Or border smoothness. Something like that. So again, we'll probably... Yeah, so maybe we'll say... Let's make the code a bit cleaner. Times by 0.4, right, okay. Times equals 0.4. And then we want a smoothness. Let's times equal by 0.1, so it's like the max value maybe, something like that. Well, the max values maybe like so if the thickness is like 0.4 on the border, then that smoothness, you probably only want it to be at most half or a quarter of the border thickness, something like that, right? It's interesting. So yeah, we'll say, you know, take away border smoothness, and then you say border thickness plus border smoothness. So those are the two edges. So anything before that is 0, and anything after this edge is 1. That's what you'll be doing, isn't it? So then if you pass in the distance, yes, anything that's, yeah, that's the thing, isn't it? You want only the in-between to be hey Voodoo, it's going alright. We're just trying to make this sort of like volcanic ground looking texture. We've got this sort of outline and the where the sort of ground still is, but we're just trying to sort of just make it nicer quality now, basically. So we're procedurally generating this texture in shader code, and yeah, just having a bit of fun doing this today. And I think we're probably going to spend a couple more streams or so doing probably like a wooden texture, you know, and yeah, stuff like that. But yeah, how's things been for you? I completely forgot, right? We were going to be doing this the whole point, the reason why we got the red going is so we could throw in some emissive. So emissive is always border color, and then like emissive strength, right? That would be like what? Well, based on how much D0 is. How much the border. So if you smooth step between 0 and border thickness, after border thickness is 1, right? So then you need to do 1 take to invert it. And then you just multiply it by something which seems reasonable. So what you then do, so you might have like some kind of, you know, brightness. Glow brightness 10. Let's see what happens there. Hopefully it doesn't crash. Oh, look at that bloom. Yeah, that's far better. There we go. I don't know why I didn't do that earlier. Yeah. I feel like I'm going to fail maths class. I need to retake the 5th semester. No. But it's the only class I might fail, so it's not tragic. Nice. It's cool. Yeah, Verona borders. Yeah. I remember making a warp shader once. It's quite annoying to fix it. Yeah. A lot of shader code that you see on like shader toy and everything, you just seem, you know, you basically just like put a bunch of maths into a tight spot and just ship it. It's you know, choose a bunch of different techniques and sort of just cram it all in there and walk away. But yeah. What but yeah. Have you do you know what things are in your maths test or something like that you can probably just do, you know, hunker down and do some research online basically and practice? Yeah, so maybe that missive would be quite a bit much, but that's the idea. And you know, I'm thinking we probably want more than just the emissive from the texture. We probably want a sort of gameplay side controllable value. And yeah, so we'll probably extend our materials kind of soonish, so we can have ways to sort of like scale the brightness, and that way you can have these things sort of like animate a bit, which would be cool. But yeah, let's just do 5. I want it to pop a little bit, you know. There we go. So yeah, that border, that's the next thing I want to do. It's kind of like they kind of got very sort of like defined edges, like it's done with a bunch of maths, right? So we probably want a way to sort of break that up. Now I was thinking of just basically changing the distance a bit, but I was thinking maybe we should just change the distance around the border edge and not the distance anywhere else. So there's like a border smoothness parameter. So maybe I should say if it's in between there, then apply this noise. So yeah, what I'm really trying to say is if D0 is less than, if this is less than D0 and D0 is less than that. Right, I guess technically it's less than or equal to, but it's floating points, so you know, but let's just get the logic looking sound. So then I want to say, right, you change the distance based on this sort of noise that you've done here. And this could, I guess, help with performance just a little bit. Not that it matters. Just apply the noise and walk away to see what happens. Right, so we're getting something kind of interesting at the edges at least, but it's not what we want. And the colouring is kind of happening afterwards. Oh yeah, well you want the colour. Yeah, so you want that. So I think if we change how much this noise is being applied, let's do 0.5. And maybe, you know, maybe that smoothness is just clearly not enough. Let's put it at 1. More smooth. It's looking better, but it's looking better on this one here, right? If I just zoom in, just get in there a bit. This one's looking better, but like the problem is you still see the edges for some reason. It's as if like right, so the problem is that the noise can bring stuff up and down, and therefore it creates some kind of like yeah, so maybe with noise, I think it returns a value between -1 and 1. If it times by 0.5 plus 0.5, then just take it away. I think. Right, that's kind of doing something that I would like, but it's not showing up as very... Let's half it again. Maybe it's not between -1 and 1. Okay, say if we absolute the value and then take it away. So we did ABS, because I don't really know what values it's given us back, and then multiplied it by 0.1. Oh, you didn't study enough. Fair play. Yep, that happens. You know, life is... Yeah, it's just... sometimes you just want to enjoy life. But it sounds like you've been doing other subjects as well. So don't be too hard on yourself. Right, this is looking better, I guess. I don't know, we're still seeing this damn thing here. Is that where it goes negative? Can I sort of like D0 max equal max? Something like that, can I do that? That doesn't really help. But anyway, let's up it a bit more. Yeah, so it's sort of producing what I want. It is taken away though. And it's still defining those outlines, which is strange. So it's like... Border thickness take border smoothness. Oh, and then we're saying from 0 to border thickness. Okay, so these are where the borders used to be. You can see the outlines. Those are right on... That's where the border's actually at. Yeah, so the problem is this noise is not going to be... It's sometimes going to go up and down, isn't it? And I guess at that border... but why are the rest of them going... Because, yeah, we're taking away the noise, the absolute of the noise, isn't it? So, I guess those pixels are not getting... So we can have a bit of fun for a second and just like, you know, say, right, distance is equal to 1, I guess. And just see what happens to those borders. Maybe it's not a good idea to do this, but we'll see. Maybe it helps us figure out. Right, and then we'll say equals 0. Okay, so we've set equals 0, and that edge is still... Okay, so clearly what's happening is that... Okay. It's not encompassing all of the... Right. So I think what we should be saying is basically from 0 and including all of it. And I think that's what we're missing. There we go. Bit better. Okay, so that's getting a bit of unevenness now, although that looks a bit weird. Right, so we can have a bit of a play around what's... So I think that's because my smoothness was just too high now. Maybe smoothness has to be probably a quarter of the... Yeah, maybe that is okay. Yeah, so we got a bit of... I don't know, that's not very smooth there. I think we can up that back to 0.5. So I'm thinking maybe... Right, let's make that times by 1. Barely did anything there, didn't it? Right. Zero 0.4. It's not high frequency. I think I need to scale this by something. That gets passed into that FPM. Make it more high frequency. Ah, I fudged that one, didn't I? Ah, it's going to be a times 2. Right. Hopefully that looks alright. Let's have a look. Let's get in there. Right, let's add in more higher frequency. That's better. Well, it's way too much, but it's adding that sort of randomness that I want. Okay. So that scale by 2 maybe is enough. I know we're still kind of seeing these. Like why is that still like polygon looking? But yeah, I can move the border down, for instance, to like 0.1 and we get less of this stuff, right? Right? And then it's, yes. That doesn't really help, does it? And it just goes and looks really bad. So say if we removed that for a second, how does it look? What's the difference? Okay, so it is making it retreat a lot. But it's just not smooth enough, is the thing. We could have tried. All right. Adds a little bit of warping there. It does look a bit better. Oh. It's interesting that that downsampled over there. Look, it seems like the red is coming through more. It's been downsampled. Oh, we might have to be able to do a downsampling differently, maybe. You might not just be able to do a 2x2 downsample. Yeah, I'll think about that. Yes, it's looking better. It's just this noise is just not. I think maybe like a simplex, maybe. Yeah, we did just try the simplex, and then we just end up doing the sort of FBM thing with simplex. Let's try that out. Higher frequency. Too high frequency, I think. Yeah. Go back to that FBM thing. Yeah, it also looks a bit weird up here. Actually, it's going to look weird because of the... We're using the normal XY and we've not done a 3D simplex, I think. Or it could be the mid level thing, I don't know. Right, I'm just gonna take a quick break, be right back. Right, welcome back everyone. Are you going to do some parallax mapping or something else to mimic the depth? Yeah, I think we're going to do some parallax occlusion mapping, but we... Is the stream really laggy or is it... Maybe a little bit delayed. Probably because of this. Right, it's cleared up now. Yeah, so... Yeah, we'll probably do some parallax occlusion mapping, but around the edges, we're not going to bother. But, yeah, you know, spheres are going to be a little bit, you know, they're going to be like a lot smaller or whatever, but, man, this is kind of weird, kind of, oh. Maybe it's selecting this the wrong map level, kind of. We're seeing pixels, man. But yeah, we're not going to be able to, on the silhouette, we're not going to do parallax occlusion map, and then if we miss, go on into the background, you know, carry on ray tracing. We're going to, after we've taken the ray hit, we'll do the parallax occlusion map, and then that's it. So you will see problems around the edges, and that's just because it'd be far more intensive to support that, and we might not really need it because spheres are probably going to be a bit smaller, you know. But that's kind of alright like that. It is showing up more red. I think the down sample is going to need a bit of a play around with. But yeah, so I think I might put a pin in it there today. But next stream we'll probably port over Simplex Noise 3D. And then we'll try and sort out this border to see if we can make it a little bit less. You know, this is kind of alright, I just want to make it a little bit better, and then try and see if we can fix this sort of pixelation problem on the corners. I think that's to do with the MIP selection. But yeah, we can see what that's about. And then we can try and sort of like maybe add some kind of texture to these. And then we'll add some kind of texture to these like ground pieces. And then maybe we can, I don't know, the emissive stuff is kind of alright. Yeah, it's kind of alright. It has these warm and cold bits. Because it's doing a smooth step thing. Yeah. So, yeah, I reckon those are the only things we have to do. And then we can tick this one off. And, you know, try like a wooden one out. And we should probably look at the downsampling as well, because I think the downsampling might need to have a bit of a tweak because we're using the octahedral map. We'll see. But yeah, we're getting some nice looking graphics now, which is cool. So very, very exciting. In the meantime, guys, there is a Discord if you want to come and hang out and chat about things. And then after we've done all this material work, we're going to go back to the plan and done all these procedurally generated materials. We're going to go back to the board or the plan, and what are we going to do? See if there's any other little features we want to add to the materials before we do a UI for the editor. And then yeah, get working on the editor. Super cool. Right, let's go and raid Kujuk. Cool. Right, have a good Wednesday, guys. Friday and Saturday. I'll see you all on Sunday. Man, Friday tomorrow. Let's go.